Hello, we are discussing about GATE 2011 ECE paper, and this question is related to analog circuits. In the circuit shown below, capacitors C1 and C2 are very large and act as short circuit at the input frequency. VI is a small signal input. The gain magnitude at 10 megaradians per second, that is 10 megahertz. What is the value of gain? Whether the gain is maximum, whether the gain is minimum, or it is unity or 0. So what will be the gain value? Is it 0 or 1 or minimum or maximum? At 10 megaradians per second, that is at 10 megahertz. Okay. So look at this one. C1, C2 are given as short circuits. They are very large such that they are acting as short circuit. That implies nothing but C1 and C2 are acting as short circuits. So whenever C1 is acting as short circuit, at that time effect of this 2 kilo ohm resistor is going to be ignored. That is, effect of 2 kilo ohm is bypassed through this C1, and C2 is going to be connected directly to the collector of C2 is shorted, so that 2 kilo ohms voltage across 2 kilo ohms is going to be directly connected across collector. Collector of Q1 and 2 kilo ohms are now they are shorted. Now if you are going to draw an equivalent circuit over here, we can draw like this. This is 5 volts battery. From that one there is an impedance. Let us assume it is ZP is the impedance from collector to 5 volts, and afterwards this is going to be a transistor circuit. Okay, and where this is connected to ground, and it is going to be connecting with input as well as signal. Okay, so this is what the voltage source, and it is connecting across, for example it is RL, and it is V0 plus minus. Okay, if you draw the AC equivalent circuit, at that time AC equivalent circuit is nothing but RL and ZP will be in parallel, so that you can write it as, okay, for AC equivalent is nothing but you can draw like this. For AC equivalent, this 5 volts is going to act as ground, so that this will be in parallel with ZP and ZP in parallel with RL. Okay, RL. So this is what we are going to get, and the current flowing through this one is nothing but IC. Current flowing through this one is IC. So if you take the parallel combination of these two things, and let us assume it is going to be ZL. ZL is nothing but ZP parallel RL. Okay, by that time V0 can be written as V0 is equal to minus IC times of ZL. That is nothing but minus IC times of ZP parallel RL. This is what you will get. What is meant by ZP then? ZP implies nothing but effective impedance across this parallel RLC circuit. This is going to be called as parallel RLC circuit. Parallel RLC circuit, and this is going to be having impedance ZP. The graph for impedance versus frequency is going to be given like this. The impedance is maximum, and impedance will be maximum at resonant frequency. That resonant frequency is going to be called as FR, and FR value is going to be given as FR is equal to 1 by 2 pi root LC. Otherwise this is hertz. Otherwise you can write it as FR is equal to 1 by root LC radians per second. This is what you can write. So if you write root 2C, this FR is equal to, it will be treated as 10 megaradians per second. You will get this one around. That is L value and C value. If you substitute these values, L is 10 microhenry and C is 1 nanofarad. If you substitute FR, what you are going to get is nothing but 10 megaradians per second. And we are going to calculate the gain magnitude at this frequency. Gain magnitude is also at 10 megaradians per second, where the ZP is going to be maximum, where the parallel resonant circuit impedance is maximum at resonant frequency, and the resonant frequency calculated is 10 megaradians per second, and we are going to calculate the gain is also at the same resonant frequency of 10 megaradians per second. So V0 is equal to minus IC times of ZP parallel RL. V0 is equal to minus IC times of ZP parallel RL, this will be maximum, okay, minus IC times of RL whenever ZP is maximum. That is nothing but the maximum output. Maximum output you will get. That is implies nothing but maximum gain. Maximum gain is possible at the resonant frequency because ZP is maximum. If ZP is small, parallel resonant circuit is nothing but the impedance is maximum only at one particular frequency, and at all other particular frequencies the gain is the impedance is very small. Whenever the impedance is very small, assume it as 0. By that time output will be 0. Okay, whenever ZP is maximum, then only you will get the output voltage. So whenever you are getting maximum output voltage, that implies nothing but maximum gain is possible for the given signal. So the gain magnitude is going to be maximum at the given 10 mega radians per second. The right answer for this question is A. Okay, since it is parallel RLC, connected the collector which is having maximum impedance at resonant frequency, and at resonant frequency only you will get the maximum gain. Otherwise that parallel RLC will give zero impedance. That zero impedance in parallel with 2 kilo ohms will be given to 0. That is nothing but output will be 0 in all other cases. Okay, thank you.